All right, let's dive into the world of cryptography. But forget ancient symbols or secret agents gadgets for a second. Today, we're going to decode secrets hidden in plain sight using the universal language of math. Get ready to crack some codes.
So let's just start with the big question. What happens when a mystery doesn't just have one secret, but two? How in the world do you find a single correct answer when you have two different pieces of the puzzle to uncover at the exact same time? Well, that's the challenge we're tackling.
We're going to call this puzzle the two-key cipher. You can think of it as a coded message that's impossible to solve with just one piece of information. You absolutely need two related clues, two keys, working together to reveal the hidden truth.
Okay, let's take a look at our first cipher. Imagine we've intercepted two messages. The first one tells us that two secret numbers, we'll just call them X and Y, add up to 12. The second message tells us that the difference between them is 4. Our mission is to find the exact values of X and Y.
Now, here's what's so cool about this. Neither message actually works on its own. I mean, if you only knew that X plus Y equals 12, well, X could be 1 and Y could be 11, or X could be 6 and Y could be 6, right? There are literally infinite possibilities. It's only by combining both messages that we can zero in on the one true solution.
So to crack this, we're going to need some special tools. The first one up is the substitution method. You can think of this as a really clever bit of spycraft. We'll use one message to figure out the identity of one of our secrets, and then use that identity to expose it in the other message.
The whole idea is this. We're going to rearrange one of the equations to define one variable using the other one. It's like we're creating a disguise for it. And once we have that disguise, we can substitute it into the second equation. This one move makes one of our unknowns just vanish, leaving a way simpler puzzle for us to solve.
Let's walk through it together. First, we isolate a secret. We'll take that second message, x minus y equals 4, and just flip it around to get x equals y plus 4. Okay, now we know the secret identity of x. Second, we substitute. We replace the x in the first message with its new identity. So x plus y equals 12 becomes y plus 4 plus y equals 12. See that? The x is gone. Third, we decode y. The new equation simplifies down to 2y equals 8, which of course means y has to be 4. And finally, we find x. We just take our new secret, y equals 4, and plug it back into our identity equation, x equals 4 plus 4, which gives us 8.
And boom! Just like that, the code is cracked. We found the one and only solution. The secret number, x, is 8, and y is 4. And you can check it. Both messages are now true. 8 plus 4 is 12, and 8 minus 4 is 4. Mission accomplished.
But substitution is just one tool in our kit. What if there's an even more direct way? Let's bring out our second decoding tool, the elimination method. Now, I love this one because when it works, it seriously feels like a magic trick. It's just such an elegant way to make one of the secrets simply disappear.
The logic here is just brilliant. Instead of substituting, we're going to combine the two messages. We're going to add them or subtract them in just the right way so that one of the variables completely cancels itself out. It's kind of like removing static from a radio signal so you can finally hear the message clearly.
Let's see this thing in action. So we stack our two messages. Now notice how we have a plus y in the first message and a minus y in the second? They're perfect opposites. So let's just add the two messages together. On the left side, x plus x is 2x, and y plus minus y, that's 0. They eliminate each other. On the right side, 12 plus 4 is 16. So we're left with this super simple equation, 2x equals 16, which means x equals 8. I mean, how fast was that? Then a quick substitution gives us y equals 4. And there you have it. This shows that no matter which tool you choose, as long as you use it correctly, you're going to get to the same right answer. Our secrets are confirmed. X is 8, Y is 4.
Okay, so we can solve ciphers, but a true cryptographer also has to know how to write them. Now we're going to see how real-world problems, plain text messages, if you will, can be translated into the mathematical ciphers we just learned how to solve.
So here's our plain text message. It's a classic chemistry mixture problem. We have two unknown quantities, the amount of solution A and the amount of solution B. Our job is to turn this paragraph into a system of equations, into our two-key cipher.
Let's break down the translation. Every part of this problem is a clue. First, we know the total amount is 300 grams. That gives us our first equation, and it's a simple one. A plus B equals 300. Easy enough. The second clue is all about the salt. The amount of salt from solution A plus the amount of salt from solution B has to equal the total salt in the final mix. Well, that gives us our second equation. 0.10A plus 0.25B equals 45. And just like that, we've created our cipher.
Now for the fun part. You're the cryptographer now. Take a look at the system we just built. Which tool from our kit feels like the best choice here? Substitution or elimination? What do you think?
Honestly, both methods would totally work. Elimination is awesome when the numbers in front of the variables, the coefficients, are opposites, like that plus y and minus y we saw before. But just look at that first equation. A plus B equals 300. It is so easy to isolate a variable. We can rewrite it as A equals 300 minus B in like one step. That makes substitution a really direct and clean path forward for this particular code.
So let's do it. We substitute 300 minus b in for a in that second equation. After we distribute the 0.10, we get 30 minus 0.10b plus 0.25b equals 45. Combining those b terms together, we find that 0.15b equals 15.
And if you divide 15 by 0.15, you get our first secret unlocked. B has to be 100. So we need 100 grams of solution B.
And if B is 100, and we know the total is 300, well, then A must be 200. The code is officially cracked. The answer to the original problem is 200 grams of the 10% solution and 100 grams of the 25% solution.
So we've cracked a few ciphers. But here's the thing. The reason this skill is so important is that it's not just about math problems. This way of thinking is like a master key that unlocks problems in tons of different fields.
I mean, just think about the GPS on your phone. It works by getting signals from multiple satellites. Each one of those signals gives you one piece of information, one equation. It's only by solving the system of those equations that your phone can pinpoint your exact location. From engineering and finance to supply and demand, anytime you have a bunch of interconnected variables, you've got a system just waiting to be solved.
I really want to leave you with this idea. Learning to solve these systems isn't just about passing a math class. It is about learning a structured way to look at complexity. It's a framework for turning confusing, messy problems into clear, solvable puzzles.
So, my last question to you is this. Now that you have these decoding tools, what complex systems in your own life, maybe a budget, a schedule, or a project you're working on, can you look at in a new light? What puzzles are you ready to solve now?